also in the homes. So we see the rules of the competition. We define a robot and see what kind of kits there are. We talk about sensors and motors, the parts of the robots, how you can use those, and what kind of kits and parts there are available, and also some words about programming. So the idea is that you get an idea about robots, how they are used nowadays, and how you could use them and how you could build ones. Of course, we are not expecting that you will build professional robots, but the best thing is that if you get a good idea and you get create something new, so you get ideas that doesn't exist yet. So you are, of course, the internet is full of things already made. You can check those and then try to find out something that hasn't been invented yet, or get an idea that doesn't exist yet. That would be the best result of this competition. So some words about my background. So I have a PhD in optimization. So I've been studying electrical engineering, automation technology, robotics, and artificial intelligence. And I specialized in optimization. So I've been working with industrial processes and doing some mathematical modeling, simulation, and optimize the production in factories and so on. And nowadays I'm a teacher in mechatronics, and we also do a lot of industrial projects with the students. So the idea is that the students work as a research and development team for the small and medium-sized companies in this region. So the students work for the companies to help them to improve their processes or products, because quite often the students have ideas that the industry members don't have. So the ones that are already doing these industrial projects, they may be stuck into their ideas and they don't get new ideas so easily. So once we have our students, they may have some novel new ideas that they can bring to the companies, and it quite often works that way. So I'm focused in artificial intelligence, robotics, sensors, and optimizations. I have also built a couple of electric vehicles, but that was let's say 10 years ago. And that's a picture of present Finland. So we got snow, especially in the northern Finland. And one of my hobbies is skiing. It's quite nice. Quite nice. So why should we study robotics or build ones? So, well, of course, you know that the robots are here and more will come. And also the robots are getting smarter. So they are not just moving arms or some other type of actuators, but the brains of the robots are getting smarter. So the robots are learning more and more stuff, and they can be, let's say, they can be taught easier. So they are not just dumb arms or pieces of metal, but they are getting brains, because the computers, they are getting better and better and smaller, so they can be used also in different ways with the robots. One trend that we will discuss later is this collaborative robots. That means that the robot doesn't need fences or some other security devices around the robot, but it can actually work with humans hand in hand with us. So that makes a collaborative robot quite effective, because in that way we can benefit from the best best things that a human can do. So we can do things, still do some things better than a robot and faster and more accurately, and our brains are still better than the brains of a robot. But if we work with the robot hand in hand, close together, we can the robot can do that boring stuff, sort of repeating stuff, and then the human, or we can work as managers for many robots, and then together, working with the robot, we can do, for example, different kinds of assembly jobs more efficiently. And of course, one major reason to use robots is to reduce costs. So robots can work day and night, and they don't really need to rest. Actually, robots like moving. So if robot doesn't move, then it may become sick. So as we human, we need to move as well. So does the robot. So that the joints and the motors stay active. They need to move. So it's not good to leave the robot alone and staying at the same place. It needs some movement. So cost is one thing, but safety also one thing. We can do some work in a safety way using a robot, so that we don't, as humans, we don't have to do some works that are not safe. Yeah, with the robots we can increase output, produce more, and we can also do it with a better quality. So sometimes for example, if we compare my hand and a robot hand, the robot hand is more accurate and it's more stable. You probably know that robots are used in the hospitals as well. They are doing surgery, or they assist the doctor in surgeries. So the doctor controls the robots, and the robot does the final cut. So it's more precise, and it can use tools that man cannot use. So the really demanding surgeries are done with the robot or by the robot. There is of course a doctor that is monitoring and using the robot. And if we have a fast enough connection, the robot can be controlled even from quite far away. From, for example, a doctor working in a different country can do the surgery using fast connections and some visualization, so he can see how the robot operates and operate from far away. Especially in Finland, we need flexible manufacturing. So we don't have any gigafactories, so really large factories, but we have to be flexible quite often so that we can produce different kinds of products in one production line. So in that kind of manufacturing, the robots and the automation machinery needs to be flexible. So they need to be easy to change, to adapt, easy to adapt to changes in the production, so that we can serve many customers, not just one big customer, but maybe more smaller customers. So the batch sizes, so the amounts that we produce are smaller, but we can change from product to another fast. So that's flexible manufacturing, and in that sense we need to choose robots and other gears as well, so that they can be changed. Here's an example of a robot doing a job that would need a lot of man labor and a lot of faces as well. So changing or installing a windshield. So in a car factory, one robot can do multiple tasks, in one step, so to say. So anyway, this kind of work needs high precision. The windshield has to be installed to a correct place, and it's quite tight, so there won't be the gap between the windshield and the car body. The frame isn't quite large, so it has to fit precisely, and the robot has to be fast. There are a lot of repetitions, so this has to be multiple times. People get tired, although they can use different machines to help in lifting the windshield and so on. But with the robot, this kind of work can be done precisely. So the windshield is attached to its place with high accuracy, and the robot can be attached with different tools. So at the same time as the windshield is placed, it can be glued, and the glue can be then cured. So there is some way that the robot uses. For example, it may use some ultraviolet light or something to make the glue hard or something like that. It can do some marking, and at the same time do the quality check. So many actions in one place. So that would take several actions from humans to do the same task. And the robot, with the help of other gears, so cameras and stuff like that, can do everything at the one step. And then the car frame with installed windshield can move forward. Similar examples, of course, can be found from different factories and different kinds of assembly jobs as well. So in order to do all of this, of course, there's a lot of designing behind that. So the engineers need to program the robot and to design all the other parts of the robot as well, quite well, in order to make it work properly. A lot of designing work to do before that, but afterwards, once it's been designed and programmed, the robot will do the task of several humans. Why to get interested in robots? So robotics. The number of robots, the usage is growing. So there will be more and more robots installed to factories, and also nowadays the robots are coming to our everyday life as well. So we will meet robots in a hospital, in different buildings. They can be used in different ways to serve us. So they can, for example, carry things. They can work as logistic helpers, or they can be assist us in finding stuff. You name it. So there are many possibilities how you can use a robot. In hospitals, you will see more and more robots, not just assisting doctors, but also assisting different personnel in different tasks. For example, in hospitals, you need to deliver a lot of different items in order to do your job in a hospital. So the nurses need a lot of equipment, and the robots can be used to transport those items. day and night, so they won't get tired. Of course, they need to recharge every once in a while, but otherwise they are quite active helpers. So the number of robots will grow. There was a small drops in the growth during the years 1920, but now it's estimated that the number of robots will grow from year to year. And if we check it, what happens in different countries, so China, although China has a lot of labor force as well, so a lot of humans, people to work at the factories, still China is increasing the amount of robots in the factories and also in the other facilities as well. So China is leading in the installations of robots. Japan, USA, Korea, Germany, so the large industry countries, they are using more and more robots now and in the future. Well, Finland is not listed since we are quite small. But anyway, you can see the trend, and the industrialized countries are getting more and more interested in using robots. So that the robots are the new normal in the industry and also in, let's say, everyday life. Because there are more and more robots are produced, and robots are produced by the robots. So that makes them also cheaper. So it's not anymore. So the cost isn't huge. Let's say 20 years ago, the cost of the robot was still quite a lot, but nowadays you can get quite formidable robots. So even the small companies can afford to buy robots and to have robot lines in their production. So the robots nowadays are a mass product. A lot of same kinds of robots are built. And then, of course, the other equipment that can be attached to the robots, they have developed as well. So there are many options how to use robots. So the versatility and also the durability has grown. So there are a lot of components available and that have already been tested and are good for the production. And once the new robots get cheaper and cheaper, and there will be more robots available, there will be also some used robots available. So robots that are no longer used by the factories are sold further, and those can be then used in testing and innovating new uses for the robots. So those are really low cost ones for the development purposes. So we can try to use the used robots in new applications, and we don't have to use a lot of money in research and development processes. So even the smaller companies can buy a robot and test it in different ways. We also have one robot with 2 arms, so dual arm robot at our university, and they are collaborative robots mainly. So and they can be used in say more precise jobs than than the robots with just 1 arm. So of course, this kind of action or this kind of a robot mimics the behavior of a man, a human. So we can teach that kind of robot similar tasks that we could do. So for example, our students programmed our robot to do some precision assembly job. So the parts that the robot had to assemble were just, for example, a couple of millimeter thick metal rods or springs that the robot could put together and assemble a part of the, let's say, faucet. That's something you can find from the toilet. So it's that the faucet is the piece that you will get the water out of. So, but these robots can do really accurate jobs, and using those two arms. And as you can see in the left robot, there is a camera attached. So machine vision can be added in different ways to give the vision for the robot. So robot will see what happens with the machine vision camera. And there can be different kinds of cameras that can tell different things to the robot. So the robot can, of course, get the shapes, get the color, but it actually also the 3D form of the object that the robot is handling. So the robot will get precise coordinates, how to pick the part and how to move the part so that it can do, for example, this assembly task. Those robots are not too strong, so they can only lift a couple of kilograms or even less depending on the robot. But they can be used to do accurate jobs. And with this competition, you can imagine how that could look like in a kitchen. So it basically looks like us. So look, just as we do. It just doesn't have a head, but the head is replaced with those cameras. So it doesn't have to speak, since, for example, if it's working in a kitchen, then all it needs to do is to, for example, chop and stir. So it needs to see what he's doing and to know what kind of tools to use. So there was already some thoughts about collaborative robots. Some say that it's at the moment it's the most effective way to do some tasks. So working together with the robot. So the robot will do the tasks that are good for a robot. So tasks that need accuracy and repetition. So something that needs to be done many times in a row and always at the same way, then it's good to be done with the robot. And then if the work needs some let's say flexibility, more flexibility that the robot can provide, and some thinking, then the human should do it. So, but working together with the robot or many robots, several robots, and then it's effective. So one human can operate dozens of robots, and the robots will do the tasks that are meant for them. That's the idea of collaborative robots. Okay, now we could check the rules. You have probably seen them already. So the basic idea is that you will develop something that is helpful in the kitchen, something that helps us to do practical tasks in the kitchen. And in this case, it's a home kitchen. So something that you could find from our homes. And the robot since it's a robot, it needs some motors to move things, move parts, move itself. And it also needs sensors. So the sensors are, the robot needs the sensors to get to know the surroundings and to see and to touch and to feel. So that the sensors are the senses of the robot. So you may use different kinds of sensors. You don't need to use every sensor listed here, but quite useful sensors are, for example, these distance sensors, so the sensors that tell the robot how far the robot is from the objects and so on. So infrared sensors, ultrasound sensors, those can be used to measure the distances. Cameras can be used in many ways. So with the camera, robot can visualize the surroundings, and even well, with the camera, you can basically do anything nowadays. So if, for example, you know, Tesla, the car that uses basically only cameras for the automatic driving. So the autopilot relies on cameras, although there might be some other sensors as well. The number of structural parts, that's not limited. So the body of the robot can be as well, you can use as many parts as you want. And you can also use devices like mobile phones or laptops as part of your robot. So the brains can be a mobile phone or similar thing. The size of the robot is limited. So this A4 sized paper that works as a guideline for the size. So it's about 20 times 30 centimeters. And we recommend you to use some kits. So it's easier to start building a robot if you got some robot kit. For example, Mbot, Lego, QRobot. There are many possibilities. Arduino has several kits that you can use. And if you have any questions, of course, just ask. And you will build a robot and submit a video of the robot. So the video will show us how the robot works and what kind of a task the robot can to do. So make a funny video and show what your robot can do. It doesn't have to do actual jobs. So if we get an idea what your robot could do, for example, if you are using Lego, you don't have to actually cook things, but just to show how you could build this robot to do something and how the robot would move and so on. And in the finals, then you will present how you did the robot. So the idea of the robot has a major role in this competition. So always a good idea. That's the best thing. And then there will be some technical part, how you build the robot, and also some coding to be done. So programming, so building the brains for the robot. So these are the rules in short. The main idea is that you will be having fun building this robot, and you will invent something new, something that hasn't been built yet, or at least you have an idea that what could be done differently. So you will probably have more and better ideas than the engineers before you. Those are the rules, and you can find them from our web page anytime. Okay, then let's go to the parts of the robot and how robots are built and so on. So robot is defined also in a standardized way. So of course that's just one definition. We all may probably have our own way of defining the robot, but in a standard it's defined with this kind of a complex sentences. But basically what it means that a robot has some mechanisms that can be moved, or the robot can manipulate or do something, so the robot can act so in different ways. The definition doesn't say what kind of a mechanisms the robot has. There can be several ways to make the robot move and manipulate parts and things. The robot is just not a dumb machine, so it needs some brains. So it has to have a control system, and most of the industrial robots they have their own programming device, or let's say that they have a computer where this control system or the program is, and they have some devices to do the programming, some tablet or similar way to program the robot. So the control system, that's the brains of the robot. So, but the robot can then basically be anything, but the idea is that it has some moving parts and then some control system that will act as a brain of the robot. So that's the way it's defined, and it's autonomous. So as soon as the robot has learned to do the tasks that are defined for him, then it will work automatically, autonomously. So it doesn't need any human to control it after that, after it has been programmed. But the robot doesn't have to learn, so it's in that sense it's just not so clever. So it just need to learn something and then repeat what it has been taught. There are different kinds of robots for different purposes. So one way to describe robots is to talk about service robots. So for example, if they help us in the restaurant or in some lobby, in the bank, in the shop, they are usually service robots. So they can talk to us, give us some guidance how to work or how to operate, or how to find some groceries, for example, from a shop, or what kind of a services a bank has, so the robot can tell about those. Or it could be working in a for example, in a hotel, and help us to get a room and other facilities. So service robots, that's one type of robot. And then of course industrial robots, and they are meant to building stuff, assembling stuff. before there were more of those industrial robots, but nowadays the amount of service robots is growing, and that the way we use service robots that's expanding. So we will find new ways to use service robots. Also, as you can see, one of the images, there's a robot carrying a patient. So in the future, there will be more and more service robots in the hospitals as well. Now, in this case, in this competition, the size of the robot was limited. So basically, the robot should fit in a box like this. So 30 times 20 times 20 centimeters. You will need to use some motors to make the robot move, or to make the robot move things. But otherwise, there aren't too much limitations what to design. So we are quite open to what can be classified as a robot. So as long as it does something and has some logic, so some brain controlling the robot, then you will have a robot. Something that makes things move in a clever way. And that's a robot we are expecting you to build. Here you have examples of three really common robot kits that can be found easily. MakeBlock makes these MBots. There are a lot of sensors and stuff that you can easily add to this MBot. The basic MBot looks like that. So it's a sort of a moving robot that can detect the environment with different sensors and do movements in the, let's say, can move in the floor, for example, and follow lines and avoid obstacles using sensors. MBot also, or MakeBlock also has robotic arms and stuff like that. Lego, those are quite expensive, but you can build basically anything using these Lego parts. So it uses these technical parts and has also different kinds of control systems, so computers. And the programming is quite simple. You can use sort of a block commands. We'll check that later. But it's quite easy to build. You have different parts that you can attach to each other quite easily, and you can make changes easily. So it's really versatile set. But as said, it's quite expensive. Of course, you get all the motors and sensors to start with that one package. And if you already have one at school, then I recommend that you check the Lego. And then G-Robot is a bit like this MBot, so MakeBlock. They have made sensors and actuators and stuff like that. So there are a lot of kits available, not just these three ones. And if you have built or programmed something with Arduino, you can use those. But probably Lego provides quite an easy way to start the robot building, because there are a lot of blocks, and you can use also the existing Lego parts, not only the ones that come with this robot kit. So you can even build a factory using these Lego parts. Really versatile, easy to build. So for the Lego, there are different sets, older ones and newer ones. So the difference is basically the main difference is this control unit, the CPU. So that has improved, and also the coding has then slightly changed. But all these different kits or sets have these motors, sensors that can be attached to this CPU, and of course all the parts in Lego world can be connected to each other. So in that sense, it's easy to use any available parts and sets. Okay, so next we will check motors and sensors. It's been now 45 minutes already. We could have a short break if you need to do some drink some water or go to toilet or something. So maybe we will have a 10 minutes break at this point, and then we will continue and check what kind of motors and sensors could be used, and also some ideas for your robot that you are going to build. So let's have a 10 minutes break. We will continue 5 to 11 Finnish time, and is it 5 to 3 your time? Okay, see you soon. We shall continue with the motors and sensors. So those are the parts that make the robot move and also give the sense to the robot, give it the senses. So the motors, of course, they can look different than the ones presented here, but these examples are from Lego sets. But the idea, of course, of the motor is that you can make something move. And if you are using Legos, there are different motors available, sort of large ones and middle-sized motors. So the difference is in the power. So the large ones have more power, but they are probably not as accurate as the smaller ones. So depending on what kind of a movement you want to achieve, you have to select a motor on the basis of that one. So if you want fast movements, fast reactions, then you need to choose a robot that fits that category. But if you need force, for example, if you are making some kind of a stew, you're making wanting the robot to move the spoon or to lift things, then the motor has to be strong enough to do the movement. For example, lift the kettle or the pan or something like that. But then again, if you want to do some accurate movements, then you need another type of motor. Or if the motor has to do some steps, so not just spin around, then you have to select a different motor. But that kind of motors you can find from Lego sets. In different in other sets they look different, but they work in the same with the same principles. So the types of motor, as said, you have to select a suitable motor for your purposes. So there are different types. Well, you're probably using only DC motors, so direct current motors, so that get their power from batteries or from the one I would describe just before, the motor that does step movements is a stepper motor, so it doesn't go around continuously, but it does moves in steps. Or servo motor, it's a motor that you can control how much it rotates, so what kind of rotations it does. So the most simplest motor just spins around as soon as it gets the message or gets the voltage and current, then it starts spinning. But the other types of motors can be controlled. The movement can be controlled better than with the typical basic motor. These motors, they are available for all the kits. So Mbot or Make Block has these, Lego has these, and there are a lot of, with Arduino, you can control a bunch of motors. So basically there's no limitation what kind of a motor you can control using Arduino. So that's quite versatile in that sense. But of course, if you are using Arduino or similar, then you need to have more skills, because you have to build those parts probably by yourselves. The Lego has the parts ready, so in that sense, it's the simplest way of starting. You can use any kind of set or any kind of parts in this one. And there are a lot of examples available, so you don't have to invent everything from scratch, or you don't have to program everything from scratch. You can use existing examples and get even parts from there. So there are a lot of parts that can be 3D printed, for example. So motors, you will need to move parts, move the robot, and then to create the senses for the robot, then you need sensors. And again, as it was with the motors, there are different types of sensors available, sensors that are dedicated for those kits, for Make Block or for Lego. So they work in the similar way, but of course how they are then built, so they look different, but they basically have the same functionalities. So you may need to use touch sensors, so to recognize where the arm of the robot is going and what it touches. So you need to know the place of the robotic arm or the part attached to an arm, for example, or if the robot is moving, the movement can be guided by touch sensors as well. Of course, that's quite an extreme way to control the movement, because basically you need a collision in order to touch sensor to work. So the simplest type of the touch sensor is sort of an on-off type. So as soon as it touches something, it will send a signal to the robot telling that now your arm has touched the wall or something like that. So the simplest form is on-off, sort of a true-false sensor. It will just say to the robot whether the sensor touches or doesn't touch something. And in this Lego part, there's this red part. If that is pushed, then there will be a signal that tells the robot there that this part has touched something. The signal can be analog, meaning that it will tell the robot so how what's the force used in the touch. So how hard does the robot touch some part or some obstacle. So then it would be a force sensor. Force sensors could be used, and they are quite useful also. So you can measure the weight of some parts with a force sensor, or as described here, you can measure how hard you are touching something. But then it's not more this kind of a on-off touch sensor, but it's the signal is different. You can tell more with the signal that comes from the force sensor. Then we go further. So these types are sort of on-off switches, sensors. So the left one was from Lego, and this could be something that you could use in G-Robot, or also the ones in Arduino might look like this one. So there are some kind of switches, buttons, or latches or similar that will recognize the touch. So if this one is pressed down, this sensor will send the signal to the robot. And also here's a button. If that is pressed, then there's a signal, and there's another one. And here, this one, if this rod is pushed, it will send a signal, and so on. So there are different kinds of touch sensors that can be used to tell the robot where it's going and what it's which parts of the robot are touching something. Infrared sensor that was also listed in this competition, really useful. So the idea of this sensor is that it uses infrared light, so it's a wavelength of the light that we can't see, but it will send the light signal, and then if it touches something, it will be reflected, and it will come back, and then the sensor measures the time that it takes to hit the object, and then it can tell the robot so how far the robot is from that object. So that will sense or find solid objects, so something from real parts, and then that can tell the robot the distance between the obstacles quite accurately. And there are different kinds of infrared sensors, so the distance that it can measure can vary from small distances to actually quite large distances. Really useful, and those are there are ready parts for those kits, and also for Arduino there are a lot of many possible infrared sensors. With infrared you can also measure temperature, but that's then a different kind of sensor. But that one is a distance sensor. Another way to measure distance is using ultrasound. The working principle is similar to infrared, but in this case, it doesn't send light, but it sends a sound that we cannot hear. So basically, there is a speaker that will generate this sound wave, and then the sound wave hits something and comes back, reflects back, and then with the receiver, that is a microphone, we can then measure how long it takes for the sound wave to travel between the sensor and the obstacles, and then we get the distance between those two. And again, there are different kinds of ultrasound sensors for Lego and other kits as well, but those are also quite usable in measuring distances. And they are quite easy to use, so there are programs ready that you can copy and paste into your program. And many examples how to use these. But by using ultrasound sensors and this kind of a distance sensors, you can make your robot move and to check the environment. So you can check the placement of your robot. But it's not, depending on the sensor, the accuracy isn't then probably not enough for all purposes, but in general, these work really fine. So most probably you will be using some kind of a distance measurement system. So using infrared sensors or ultrasound sensors or different kinds of touch sensors to make your robot work. You may find use for other sensor types as well. So there are lots of different kinds of sensors. I already mentioned the force sensor. So with that you can measure, how hard you are touching something, how much does something weigh. But you could invent something, or you could get an idea how to use moisture sensor in your kitchen application, in your kitchen robot. So that moisture sensor will detect how moist something is, or you can check whether the, for example, if you are using different kinds of raw materials in your kitchen, then you can check the moisture of those raw materials with this one. You can monitor humidity, temperature. That could be useful in your robot. So if you want your robot to be aware of the conditions in the kitchen, maybe you are inventing something to be used in a fridge. So checking how cold some food is, and for example, or how hot the food is that you're preparing, you may need temperature sensors. There are different kinds of temperature sensors. In some sensors, you need to touch the particle you are testing, or then there are also sensors that can detect temperature from a distance. So you can use, for example, infrared to measure temperature. Then you don't have to touch the stuff you are measuring. So infrared is quite useful for that purpose. And there are different kinds of sensors available. And the Arduino uses sensors that look like this one, and also the motion sensor could be from Arduino or from other sets as well. So they look quite similar in different sets also. Here I have listed only a couple of sensors, but once you know what you want to measure or what you need to know, then you will find out or find a sensor that will provide you that information. But these are the most common ones, so to say, that you might need in this project. How to sort of give eyes to the robot. So there are different ways. Of course, these distance sensors, they are one way to provide eyes for the robot, but then there are other sensors as well. So if you don't have to get the image, but you need to know the color, then you can use sensors that are meant for detecting colors. So there are different kinds of color sensors that could be really useful in your case. So if you have to, for example, know when to pick tomatoes or something like that, you need to recognize red color, and you could use in the simplest way, you could just use color sensors to detect tomatoes from eggs, for example. Stupid example, but something that you could use. So for Lego, for M block, make block, there are color sensors. And also you can find a lot of tools and examples how to use those color sensors. Here are some example codes when you are having this kind of a block programming. So you can define what you are measuring with this color sensor. So which color is in question, and then so basically you calibrate or teach this color sensor to recognize the item that you are looking for. And there are different ways of doing it. In the simplest form, you use these kind of blocks that have parameters that you can define and change and teach the color sensor to provide the proper information that the robot needs. Quite easy to use. Sometimes there may be difficulties because the light changes, so the brightness of the surrounding is maybe different. So if there's a sunlight and then the color sensor works differently than when there's a night and you are using lamps. So the type of the light around the sensor affects also the work of the sensor, how the sensor works. Here's just an example picture of this M-bot. So that can be taught to move in a maze. So using different kinds of sensors. So now in this image, the M-bot has already hit the wall. So now there is a ultrasound sensor also, but the robot has gone too far and hit the wall. There might be a touch sensor telling that now you're exactly facing the wall, and then your program would tell the M-bot to turn 90 degrees and go on in order to find the next wall and next opening. So this kind of a maze problem is quite common. So when you are doing this kind of a problem solving, that you need to teach the robot how to move and how to find a way through the maze. And also you can teach the robot how to remember the route that the robot has already gone through, so it doesn't go back with the same traces. But that's just one example how you could use distance sensors to make the robot move. In this, in our case, the robot would move in the kitchen. So it should recognize different obstacles and find its place in the kitchen, so that it can help us somehow to operate in the kitchen. So we went through some motors, sensors, a couple of words about programming. All these kits, so they are starter kits, so something you can start with. They all have their own, let's say, programming language, or how they teach you to program. That's an example from this Gara block. The ones that Lego uses and also Make block, they are more or less similar. But then the way that you program is that you connect blocks to each other, so that you sort of build the logics of the robot using these programming blocks. So there are different kinds of blocks that have parameters, so you can change some parameters in these blocks. So for example, here we have this blue block for doing the movement. So then we can tell the robot that if the program comes to this step, so it faces this blue movements block, then in that one, the robot would be told that move 10 steps. And then if you are teaching or telling the robot about some colors, then it would have this block. So the program is built out of blocks, and the program then rotates or moves on from step to step, and each step tells a robot what to do in that step. So you are telling the robot step by step what to do, and you have this kind of if blocks also. So if the robot finds something, let's say new, then you will tell the robot what happens when you, for example, hit the wall or you move your robot arm to some point, what needs to be done next. So if you find out something, then do something else. So there are different blocks that can be used to tell the robot what to do in each situation that the robot might face. So these blocks are quite logical to use, and you can just start by try some simple, let's say, chains of blocks, and see what the robot does, and then you will learn how to use these blocks. The programming language that's written basically in the same way, but instead of these blocks, there will be text saying the same thing. So, but doing this in a sort of a visual way is a good way to start. So you can see the steps that you have programmed for the robot, and then you can see what each step means, what the robot has to do in each step. And then there's behind that, there is a programming language, but you don't have to take a look at that. You just need to know what these blocks do. They will do the rest.
Hello.
Yes. Hello. Was there a question? No. Yes, and for each sensor block also. So if you're using sensors in these kits or sets, the programming language, the block code, has then blocks for those sensors as well. So for infrared sensor, there is a block, and with this block, you can then define the parameters of this sensor. So how this sensor operates and what kind of information you would like to get from that sensor. So for example, if you get the distance from the sensor, then you can tell the robot how to operate when the robot gets that information. The same thing for color sensor. These examples are from Lego, but they would be similar for other kits as well. So you have a block that you can use to tell the color sensor which color to look for, and how that information is then passed to a robot. So with these ones, you can already give it some sort of a vision for the robot. So the robots can see the distance and see the color. Of course, you can also use cameras. So from the camera image, you can detect basically anything, as I said previously, but then again, you will need some more programming in order to use images. So that's more advanced programming. Of course, there are examples ready for those purposes as well. So you can use machine vision systems as well, but that needs some more expertise. So these ones are quite easy to use. But if you want to get more information, then you may need to use real images and machine vision systems, but that's also possible. So as I said, that behind these programming blocks, there's some code. If you're using blocks, you don't have to see the code or understand the code. But if you want to operate using code, of course, that's also possible. But that's how it looks like when it's done with the blocks, and then the same with the Python code. For some, that this kind of a text code tells more and it's more clear. But if you are starting the programming, then probably using these blocks is a better idea. But of course, you can always check what's behind the blocks to see how it's written as a code, well, in a text format. But if you're just starting the programming, try first with the blocks, and then as soon as you know what you are doing and you want to get into the detail and check the code and how that is done. So as said, you don't have to start from the scratch. There are lots and lots of projects done with all of these kits, and especially with Arduino. So there are many examples that you can check, and a lot of code existing that you can just copy, paste, and modify so that it fits your plans and what you are planning to build. So these are development environments, then they are used when you are doing the actual code, and they will help you in doing things right so that the code is correct. And so if you are doing it the easy way, then you can start with this Lego Gara block or Make block, and more advanced would be then using Arduino and then different platforms and suits for Arduino. But as said, you don't have to know everything at the beginning. Just search for examples and check what has already been done. So the CPU, that's the brain of the robot. Lego has one. Make block has one. Always there's a CPU or a small computer present or active in a robot. So in a Lego, it's called intelligent brick. So that's the brick where you upload your program. So you can do the programming with your computer. Then you will send your program to this brick, and then the robot has all the information that you have programmed. So this kind of a CPU gets information from the sensors. That's the same with every CPU, whatever the type is, there will be some input ports that will provide information. So from the sensors or whatever there might be from different voltages, any kind of input for the brain of the robot comes through input ports. And then it will be operated here. The program that you have done and uploaded here will see those inputs and act based on those inputs. So for example, if the touch sensor says that now we are facing the wall, then the program decides what to do next. And how it's done, you will have these output ports. So once you get input, we are close to the wall, your program tells the robot, okay, then we should turn around and go to a different direction. And then it will control the motors moving the robot. So there's this brain in the middle of everything, and the brain gets the information and transports the information further to make the robot move or do the things that you want the robot to do. So that was the example for the Lego. So MBOT, it looks different, but the functionalities are the same. So there will be these sensors. In this example robot, there's ultrasonic sensor and line follower sensor. So basically, the line follower is designed to see black line and follow or give information about that. But the brains are here. So it will get input from the sensors and then send information to motors and to other parts to make the robot move and do the things that you program it to do. So sensors, brains, and then some actuators. That means some parts that make the robot do the movement and actions. They are always the same. They look different, but you will find all those components from your robot as well. Some other pictures of CPUs. So the popular ones, they are this Arduino. So there are a lot of different versions of these CPUs, microcontrollers, built for this Arduino development environment. So they are the basic ones, and then there are different sizes of these. So if you want small controllers, then you will use these nanos or similar ones. But the working principle with this one is the same. So most of them are equipped with some wireless networking system. It could be Wi-Fi or Bluetooth or something similar. So you can control these wirelessly. And in some cases it's built-in, but in some cases you need to add a block here that has this wireless connection. But anyway, these are quite widely used, the Arduino ones, and there are a lot of examples for those ones. So you basically just need to get a kit of Arduinos, and you will then find examples how to use them. Arduinos are also quite cheap. They don't cost too much. So you can try any kinds of ways to use those and try if they are good for your project. The Arduino kits, they will cost a couple of tens of, well, I have to say euros or dollars. And then the sensors, they will only cost, let's say, a couple of dollars each. So those are quite affordable ones to get. And I said, a lot of examples ready for those. If you are not using Lego, the Lego has many parts that you can use to build the let's say body of the robot or the frame of the robot. But if you're not using Lego or some other kit that has these body parts as well, then you might want to use 3D printing. I guess you all have access to 3D printers, so at school or at some other place. And then there are actually no limitations for you. Then you can design anything you want, and then use that model in your robot. And what you have to learn or know when 3D printing is, first you have to design the 3D model. There are quite a few free software available that you can use to design your part and then send it to a printer to get it out. And you can start from your sketches, also you can draw the first model by hand and then start remodeling it with a 3D program and then print it. So you can print housings, so bodies or frames for motors with 3D printing. You can print, for example, the arm or legs or anything of the robot with the 3D printer. Basically, you can do everything with 3D printing. So not, of course, you have to install the motors and the wiring and so on. But let's say all the body parts, the housings, the boxes, that's something that you can do with 3D printer. Of course, it takes some time to get the parts, but it's really flexible way of designing your robot, so you can customize everything. So if for example, Lego has only a limited amount of different parts, but with a 3D printer, you can do anything. So, and it's also not so expensive. So these plastic materials for 3D printing, they are not so expensive. Probably you will make some mistakes, so you have to redesign your parts. That the first designs are usually not the best ones, so you have to make some parts in order to find the best possible part. But I'm quite sure that some of you will be using 3D printing in this project. And the rules stated that you can use your cell phone or some other as a control device, or you can even invent something, some kind of a robot that will help you to use your cell phone in a kitchen in a better way. Of course, for example, you can get different kinds of recipes with your cell phone. Could that be used as a part of your robot? Or even a laptop or some tablet or something. So that's allowed, and maybe even a good idea, because quite often we are using our cell phone for everything. So if you can connect cell phone to this project, you might get something really fancy. So those can be a part of your robot doing something. It doesn't matter what they do. So that's free to innovate. So you can try to find a new way of using cell phone in a kitchen to help to do some food, or to prepare food, or to create a new recipe, whatever. It's up to you what kind of ideas you have. The cell phone's camera can be used in different ways. So there's ways to use cell phone's camera for machine vision to recognize things and so on. So in that sense, it can be really, the cell phone can be a really versatile tool for you, since it has these cameras and so on. Sometimes it's not so easy to connect your cell phone to a robot, so there might be some difficulties, but you may use it. And I have already said many times that there are a lot of existing projects that you can check. A lot of ideas that have been transformed into computer programs or done with robots. So just search the internet. If you already have some kit, make block or Lego, then find similar projects, but then invent something new. Don't just copy, but invent something new that you think is good for this project and something that you would like to have, or you know that something someone else would like to have. For example, if you want to help your parents to work in the kitchen, invent a tool for them. But check first what has been done and how it has been done. So you will learn a lot by following those examples that are widely available in the internet. So free codes are available. You don't have to program everything by yourself. Get the code, modify it, and then make it work. There are some robots already. These are more like done with the industrial robots or in a let's say professional way. That's an example of the robotic pasta kiosk. So this robot makes pasta, so it has different recipes and it provides pasta meals then. So, but that's based on the industrial robot working in a kitchen. So of course, you could also have access to some industrial robot or similar ones. Not probably industrial, but there are small robotic arms that you can use in your project as well. So you don't have to build everything from scratch. That's just one way of using this kind of a standard robot to operate in kitchen. And another example, that's a Google robot. So that robot can also move. So it has motors that can also make it move. So it has tires also. So it can be used in different kinds of tasks in a kitchen and other places as well. So it can pick up things, grab things, it can move, it can detect different items. So it has this different sensing sensors, so cameras and distance sensors attached. So it can be taught to do different tasks in a kitchen or in other facilities as well. So engineers have already designed robots for different kinds of purposes. And now your idea is to create some new ideas how to use robots in a kitchen. That's another type of service robot. So these robots have these places where you can place a tray, sort of a food portion here, and the robot will then deliver the portions, or they can deliver anything that is placed there. And those robots also sing, so you can make the robot sing a song as it moves around the restaurant. Of course, some may not like the idea of a singing robot, but some do. So there was just a couple of examples that have already been done. And now it's time for you to create your own idea and to build your own robot. So be innovative and get your own idea. And if you have any questions, then just ask. So you have our addresses, and you can address your asks to any one of us. So it will be then delivered to the one that has the best answer for you. But thank you for this session, and good luck with the competition, and be creative. Thank you.
Thank you, Petteri, very much for the lecture. And this has been recorded and will be added into the net pages of the competition. So I guess that it will be there tomorrow. And as written there into the chat, we will have more lectures this week. So tomorrow, there's a training session on how to run a neural net as part of your robot software. Mr. Torni Aaltonen will be there tomorrow. And then on Wednesday, there will be a lecturer from SAMK, our partner university. Mr. Teemu Saarelainen will tell about introduction to Arduino CC++ programming. So please, you can come online then and listen to these lectures too. But if you have some questions, we are here now, or you can write competition-related questions to the chat, or you can use the email address which we have written there and write your thoughts there too. So it's like that. Are you adding me the RoboGo address, please? So my colleague will add the address once more there into the chat box. But thank you for listening. And if you don't have anything in your mind at the moment, I think then that we can end the session. And we hope that you will register your teams to the competition. Thank you very much.